This is a quick walkthrough of several products Azumo has built that leverage computer vision. We are using DINOv3 plus SAM3 pipelines. We have 3 different pipelines, and what changes between them is the dataset. Different datasets allow us to fine-tune models to specific applications, and that in turn gives us much greater precision. And of course, we build custom applications on top of these pipelines. For instance, this is a detector for architectural surfaces based on a DINOv3 SAM 2.1 pipeline. And we have a number of tools here that allow us to manually clean the rooms, walls, and everything else that gets detected. Let's get rid of things here, simplify this polygon down, and edit the polygon. This is a tool that allows builders to quickly create estimates around the work they need to do, like what's the surface area for tiling, ceiling work, paint on walls, and so forth. We are able to run this with different pipelines for different speed, GPU consumption, and accuracy. The best quality pipeline is DINOv3 plus SAM3. DINOv3 plus SAM 2.1 brings what I would call the best value. And SAM3 just on its own creates strong results for segmentation, but also produces more false positives and errors. However, it's extremely fast. Let's move to a different application, skincare. In skincare, we also have a couple of pipelines. This is the SkinDoodles project. We can mount a dataset here and run a detection with DINOv3 plus SAM3. Let's say this photo. At that confidence level, we're finding eye bags. This other photo at this confidence level is finding different features. Enlarged pores, eye bags, acne, and others. This is a very small data set, which is why you'll see some error here, but it was also a prototype built in a day. Let's try a different case. Something like this is finding 67 instances of acne and 7 instances of oily skin at the lowest confidence interval of 36%. We could run the same analysis with a different pipeline. This one is less accurate. It's finding far more detections. But that doesn't necessarily mean they're valid or that the quality is as good. That leads us to our third application, SteelSight, an industrial defect detection tool. We can mount the NIU dataset, which is a standardized dataset for this kind of application. Defects in metal surfaces. I have a DINOv3 plus SAM2 pipeline. And I can adjust sensitivity to find problems here. This also works on stills or frames from video. And by adjusting the sensitivity, I can get more or fewer matches. Let's try with DINOv3 and SAM3. Here you are going to see the best quality, but also the slowest response time. This is very high quality. And it is not only finding the outlines, it is also classifying them into a set of defect categories with reliable confidence levels. So DINOv3 makes the first pass and identifies bounding boxes. Then SAM3 classifies and identifies all the polygonal boundaries that match. And again, this is capturing nearly everything here, including minor surface artifacts, even the flowers that fell on this car, but also real problems like scratches, bumps, and other surface defects. The last thing I'll show here is the benchmark laboratory. This is super important. We're going to measure a number of pipelines, including some that aren't selectable in the main interactive application, and process a number of images. I'll use 3 images so it runs quickly, and because I know the results will be representative. We're measuring several things. Average time per image is important. Mean foam, precision, recall, average precision, mean average precision. These results tell us how good each pipeline is in terms of quality and how good it is in terms of speed. So you can see that DINOv3 plus SAM2 is actually even better than DINOv3 plus SAM3 on these metrics, which is the benchmark for segmentation quality. And by using just the DINOv3 on its own, pre-trained, we're also outperforming that combination. So this is probably the best value in terms of precision and speed. Another important metric is MIOU, mean intersection over union. This statistic is related to MAP and measures the overlap between what was predicted and the ground truth we have for each one of these samples. Here we have a full report. We see that SAM3 by itself is very good in terms of MIOU, but the combination of DINOv3 and SAM2 gives us the best mean accuracy. The numbers aren't exceptional, but that's a function of the dataset size and the evaluation criteria. We would expect something around 50% or above to consider it production ready. And that's the full DINOv3 demonstration.